Okay guys, this is your video for geometry SLO review worksheet number 12. It's parallelograms in the coordinate plane. As you can see, we have to graph each quadrilateral with the given vertices, and we're going to use any method that we want to determine whether the figure is a parallelogram. We are obviously working with problem number 4, and again, you get 1 or 2 problems and then you have to do the rest. This is just to refresh your memory as to how we can prove something is a parallelogram in the coordinate plane. Now, the first thing that we're going to do is, obviously, it says graph, so we're going to want to graph. And I'm just going to graph all of my points. A is at 1, 8, and please, please, please remember to label so that you know what you're doing and what you're looking at. So A is at 1, 8, B is at negative 7, 7, negative 7, 7, right? C is at negative 6, 1, negative 6, 1 is right here. And D is at 2, 2, D is at 2, 2. And obviously, I have a quadrilateral. I don't know yet if it is a parallelogram. I'm not sure, so I can't call it that. I'm just looking at it. It's a quadrilateral. It's got 4 corners, or 4 vertices, there we go, and then 4 sides, along with 4 angles. Now, here's what we need to do. You have several methods, okay? We had where you could compare slopes, right? And so I would have to then compare the slopes of BC and AD, and those 2 slopes would have to be the exact same, and AB and CD, those 2 slopes would have to be exactly the same, because if our slopes are the same, then our lines are parallel. That is not the longest way to do this, but not the shortest either. The other way that we can do this is using our distance formula, right? Distance formula, which we're not going to get into. I'm just reminding us that we could. And again, what you would have to do is you'd have to say, okay, the distance from B to C has to be the same as the distance from A to D, and the distance from B to A is going to have to be the distance from C to D. Okay, so those distances would have to be the same. Opposite sides are congruent. Again, not the way I'm going to go, because that one is actually the longest way. Okay, the third option that we learned, and that you hopefully kind of remember, sort of, kind of, maybe, possibly. Okay, the other way we looked at it was, if we look at our diagonals, and it has to be the diagonals, we are looking at the midpoints of the diagonals. Okay, so I'm going to draw my diagonals in from B to D. Okay, I'll switch to another color. Oh, let's go to blue. A to C. Okay, if the midpoint of those 2 segments, if the midpoint is the same point, okay, then our quad has to be a parallelogram. So all I'm going to do then is I'm going to solve, or not even really solve for, because it's a really simple formula, the midpoint of BD. So I will start with BD. I'm going to start with segment BD. Okay, the midpoint, remember your midpoint formula, and I'll write it off over here. Remember, it's just x1 plus x2 over 2, comma, because remember it's a coordinate, so then it's y1 plus y2 over 2. Okay, it is a coordinate. It's going to be an xy coordinate. So when I am working with BD, I'm taking the point B, the point D, and I'm trying to find the midpoint between those 2 points, or the midpoint of that segment. So then it is going to be a negative 7 plus 2, okay, all over 2. And then if I look, I've got a positive 7 and a 2 for my y. Okay, so then a positive 7 and a 2 for my y. And then all I have to do is simplify this. So negative 7 plus 2 is a negative 5 over 2. And then a 7 plus 2 is a 9 over 2. And I can leave it in improper fractions. I can write it as a decimal if I need to. I can write it as a mixed number if I need to. But ultimately, that is as simple as it gets for me. Now all I have to do is go and check the midpoint of the other diagonal. The other diagonal is AC. Okay, so we're working with that one now. And again, we're just going to use the same formula, the x1 plus x2 over 2, comma, y1 plus y2 over 2. So when I go for A and C, A is our x value is a 1 and a negative 6. So 1 plus negative 6 over 2, comma, and our y values are 8 right here and a 1 right there. So 8 plus 1 over 2. And again, once I've plugged everything in, all I have to do is simplify. Oops. 1 plus 6. You notice I put my bar on the wrong side. We'll deal with that later. 1 plus a negative 6 is a negative 5 over 2. And 8 plus 1 is a 9 over 2. And notice, these 2 are the same point. Okay, so our diagonals bisect each other. Okay. The diagonals bisect each other. Okay, because we know this because our midpoint for each segment, for each diagonal, is the same. Okay, so because our diagonals bisect each other, not bisector, okay, bisect each other, we have a parallelogram. Okay, so again, you had your, I'm running out of room, parallelogram, there we go. You had your three different ways to do this. You can do slopes, you can do distance, or you can do the nice, easy, lazy way and just check the midpoint of your diagonals.